All right, so I'm Prasad. I'm Director of Engineering at Acceldata. My talk today is about how we do SaaS releases at Acceldata, balancing speed, safety, and scale. A little bit about Acceldata before we start, right? We are a data observability company. What we do is, we manage the reliability of data on customers' data infrastructure. So if you look at it, right, if you look left to right, we manage data at rest. So we do reconciliation of the data, profiling of the data, data drift, to see if there is any anomaly in the data. We do pretty much the same thing for data in motion. So while the data is flowing across the customer's pipeline, we can do pretty much everything that we do with data at rest. The other three sections are around cost optimization and spend management. So we manage customers' cloud data warehouses, right? So cloud data warehouses like your AWS EC2 instances incur cost. So if you have such an infrastructure, this tool will let you know how much you're spending, how are you spending, and optimize on your optimize the spend that you are making on your data infrastructure. Okay. So this is a little interference. Okay. I'm audible? Okay. All right. So this is the service infrastructure that we have today, right? About 89 services that make up our SaaS service, right? So the SaaS functionality that we expose today is, this is roughly what it is, right? The ones on the top that you see, that's our control plane. So those are managed by Acceldata and hosted by Acceldata primarily on an AWS infrastructure. The ones at the bottom, that is what our customers deploy, and it is hosted in their VPC. This is where the heavy lifting as far as the data is concerned, right? So we pick data from the different data cloud warehouses or databases, run the different rules on it, right? So this is where all the heavy lifting is being done. We use a monorepo. So whoever has used monorepo, you know that, right? It's the entire code base is in our in a single repo. It's good. It gives us a lot of convenience. Build happens very quickly, but then you end up building everything. The build takes longer. So it's good until it it brings it its own set of problems, right? But that is where we are as far as our services and the service delivery is concerned. The quantum of change. So we are a B2B company, right? We don't make like thousands of releases. That's not the quantum of change that we have. We make about the last 1 year worth of data. This is we have had 35 major releases, 105 patch releases. A major release is about 150 PRs. A minor release is about 25 PRs. On an average, we change about 150,000 lines of code every few months, right? So that's kind of the quantum. And then we release once every 4 days, okay? And our objective, although we do release very often, we want to be able to release very often, but our objective is not that. Our customers who are running these data pipelines, they don't intend to see changes very often. Even if we release something, if something is working in their environment, they don't want to change their environments as frequently as you would see in a B2C kind of an environment. Additionally, we have these integration points, right? And these are integration points like, we would have data warehouses like Athena, Redshift, Snowflake. We would have orchestration like, Airflow, or you would have a ticketing system like Jira. These are all integrations that we do support today. So on last count, there is about 63 such integration points that we have. Right, so those are the problem statement, right? So as far as our services are concerned, we have a wide range of services, many services. We have fairly reasonable amount of releases going out, and then we have large number of integration points. So the complexity, like everybody is aware, right? And every time you make a release, you have to test out everything. You have to make sure that everything is working fine. And only then you can make a release, right? Anybody who has sold to enterprise customers, you will also know that, quality is one part of it, but vulnerability management, right? You will need to make sure that we do use a lot of open source libraries today, right? And these are open source libraries bring their own set of vulnerabilities. Since we are selling to enterprise customers are paranoid about having these deployed in their environments, right? So vulnerability management is another part that we have to really take care of. So our stated goal was where we wanted to have an approach where we shift left. That is, we wanted our developers to have the capability to test early in the cycle, and that too, an ability where they can test the entire integration test environment. Not just a bunch of services which they can deploy and test it in isolation, but the entire set of services that we have deployed in an environment and be able to run integration tests on that environment. Right? That was the first point. The other one was, we wanted to bake vulnerability management into the development cycle, and I'll elaborate on it a little later. The other part was, trace test execution, right? Now, like we set the context, right? We have about 90 odd services that we have. The versions of these services can change independently, right? Although we have a monorepo, doesn't mean that, we release 4.3.0 in one release, the next release is going to be a 4.3.1, right? It could be that a subset of services would be still 4.3.0 and another subset would be 4.3.1. Add to it the complexity of having several open source components, right? So you have, an example would be temporal, right? So it could be running its own version. It doesn't have to do anything with our the artifacts that we deliver today, right? So how do you manage to track the exact versions of all the services that you have tested against, right? So that was another problem. And then make sure that you're promoting the right configurations across environments. So you have tested something in your test environment. How do you make sure that it is those artifacts that are getting promoted, right? So those were our stated goals to begin with. So this was kind of the blueprint that we started to work with, right? We thought having a Git feature branching approach would be the ideal one for us because we had several developers who were cutting down their own branches from development, pushing their features into their feature branches, and then pushing it into development, right? So we thought, feature branching is something that relates to our existing practices at that point of time. And by the way, just to mention that this is something that we took up an year and a half back, right? So feature branching was something that we thought, would be fitting in. So developers commit their commits into the feature branch. They should have the ability to spin up their own microenvironments where they can test their features. Once they are tested it, they make sure that everything is working fine. A PR gets raised. The CI cycle should bake in everything that we want to test or validate, right? So code reviews, code quality, build, deploy, test, and scan, right, for vulnerability. Those are things that are baked into the CI. And then we have a set of well-defined environments, right? Unified is our QE environment, where if a CI passes, it gets merged into the mainline branch. The artifacts get deployed into the QE environment. Regressions run over there. Those regressions, today it has been, it's a huge suite running about 20,000 tests every night. And once that regression is certified, we move on to the pre-prod, which is our staging environment. And finally, we go into production, right? So that's kind of the blueprint that we wanted to come up and follow, right? And we wanted to shift the validation all the way towards the left, meaning any development that gets done on the feature branch needs to be tested at that stage before it comes even into the earliest named environment, which is unified in our case, or generally it would be the QE environment, right? So that brings in Sentinel, right? This is our internal platform for developer productivity. These were the goals that we came up with based on the blueprint. We wanted a fast and granular builds. Sorry, my timing is a little off. Quick deployment of services. It should be able to execute test cases. It should do early continuous. Sorry, I made a GIF of it, right? So it doesn't go back now, but I'll read it out. Okay, it does. So early continuous vulnerability detection, CI, and promote and test on standard environments, right? So these were the, based on the blueprint that we came up with, right? These were the high level goals that we wanted to follow. And on top of it, we wanted it to be a self-service platform, right? So any company that I have previously worked with, if I needed an environment, I had to go to a DevOps team or raise a ticket and say that, no, I want to test this, give me an environment. Or if there's a build, there's a nightly job that keeps running, I go and pick the builds from there, right? Um, so there was a lot of dependency on other teams. We wanted Sentinel to be something that is self-service. People can come in, do their builds there, deploy environments from there, create micro environments, run their tests, do the promotions, right? So the whole nine yards of how you get a software from the initial development stage onto your production environment is something that Sentinel enables today. Okay, so let's coming to the first concept, right, where we said we're going to touch upon three concepts. Okay, we are going to look at how we do microenvironments, how we do vulnerability management, and how we track tests against a particular configuration and promote those configurations to production, right? So first of the concepts is microenvironments. Okay, this came up. This is something that I saw on LinkedIn. Really resonated with what we were trying to do. So we didn't want named environments. We just wanted environments where use and throw kind of environments. We bring up environments, use them, test it, change configurations, whatever you want to do, upgrade it if you need to, and then delete it. As time goes by, right? So no dependency, right? You don't. It's not named or anything, right? That's what Cosmos does, right? So that's one of the tooling that we have built over a period of time. Uh, it's uh, it's Kubernetes as a service. Okay. What we have done is, we have taken Kubernetes. Our first version of Cosmos was based on namespaces. We took whatever was getting deployed in our production today and started running it within a namespace. So each developer would end up getting one environment of their own. But namespaces had its own set of problems, especially for resources which were cluster-wide, which we wanted, if a particular environment just needed some configuration, that was not possible for us to do. That's where we came to leverage virtual clusters, right? So virtual clusters runs within a namespace. It gives the impression that it itself is a Kubernetes cluster, right? All the high-level resources, CIDs, for example, it manages it as part of the virtual namespace. All the low-level resources are synced with the host cluster, so pods and all will be synced with the host cluster. But it gives you an illusion that you're running your own Kubernetes cluster. So each developer who goes and spins up cluster would end up getting a namespace and run their entire cluster. So mind you, this is not just uh, a bunch of services where what developers have changed is running. This is the entire Acceldata SaaS infrastructure that is running in their virtual namespace, right? So they run the whole environment. They can test it. Obviously, it's a scaled down one. Okay, so you won't be able to. If you need to do a performance testing, this would not suffice. But for any other purposes, this is more than sufficient. This is just to demo, how do you end up creating a cluster, right? So a developer today doesn't need to be aware of what's happening deep down in the Kubernetes cluster. They go to Sentinel and they create a cluster, right? So that's all the all that a developer needs to do as far as requesting a cluster is concerned. And this is what a cluster listing would look like, right? So these are pretty much nameless. We don't use these names. It's not like these are long-running clusters. We'll create them and we'll delete them when we are done with it, right? So Cosmos has been a game changer for us. We have had the ability to create clusters now. We have been able to test our infrastructure very thoroughly, very beginning of the cycle. Even so developers use it obviously, but even QE engineers use it to develop their test cases, run integration tests on feature branches, so that before even if it is getting deployed into or being merged into your mainline branches, bulk of your testing is already done on your CASMOS environments, right? So that reduces our regression payload that we used to find by a very high degree today, right? And it has it has helped us to move shift left, right? One of our initial learnings, we used to run this on on an AWS environment. The cost was prohibitive. We couldn't do a lot of environments at the same time, owing to the cost on the AWS cluster. We have now moved this onto a co-located data center, commodity hardware. The cost of running one environment today is about 24 cents an hour, right? So that is all it takes us for running an environment, scaled down version of an environment, and be able to run tests over there, right? So that has been a revelation. But there are trade-offs, right? If you're running on AWS, you don't have a lot of overhead as far your DevOps team is concerned. But today we do have a lot of overhead, because DevOps teams have to manage this. Yeah, that's the cost that we incur. Highlights, today we have the capacity to run about 70 odd Cosmos environments. That is practically one per engineer that we have today. And it's fairly reusable environments, right? So they can do whatever they wish to do with these environments as far as testing and development cycles are concerned, right? So the next topic was around the release descriptor, right? So we talked about 90 services, developers or QEs are running tests on these environments. How do you track what is getting tested? What is the service configuration when a test was run? And then how do you decide, that this is what I want to promote to our next environment, right? I've just given a illustration of a service descriptor here, where your versions keep changing ever so often, and these get deployed in your environment. So this could be your Cosmos environment, where you are deploying a bunch of services, running tests on it. You capture the state of the service at that point of time, and then you can take it from there onto your QE environment and to your staging environments, and eventually into your production environment, right? So today this is how a cycle would look like for us, right? What we have, so let's say we have a full release, right? The initial development starts on a feature branch. Developers start making their commits. They run their unit tests. They run their integration tests. Goes through the CI process, and the code lands on your development branch. And from there onwards, you deploy that onto a unified environment, which is your QE environment. And when you deploy onto your QE environment, that is when a release descriptor will get created. And if you look at the top, right, as many number of times you have initiated a deploy, it would result in a new release descriptor. And every time a test gets run on a release descriptor, it will get tracked against that particular release descriptor, right? Today, as per our process, right, we have a development branch. The initial set of testing happens on a development branch. Once the QE has signed off a development branch, that is when a release branch gets cut out. Again, the process will follow. You'll get a release branch, and on the release branch, you are testing you have your own set of release descriptors that get generated, and eventually, you will sign it off on. So this stage here, that's where you're signing it off on the unified environment, which is the QE environment. And once signed off, it will get pushed into the pre-prod environment. So it is an auto promotion which Sentinel handles. It takes a reference of the release descriptor that was signed off and gets promoted into the pre-prod environment. And the next steps continue there, right? So on pre-prod, you may have found a bug. You will have a new release descriptor. It gets tested. It results in the generation of a new release descriptor. That release descriptor gets signed off. And eventually we have the approval process where the DevOps, PM, this is a configurable configuration that we have, in terms of who needs to approve a release, right? And finally, it will auto-promote it to production. So this entire cycle is today managed by Sentinel. This is just a demo of how a release descriptor gets created. So this is a view of Sentinels. You have a new build that is getting generated when a developer goes or a QE person goes and says, I want to deploy this on that environment. That is when a release descriptor gets generated. Release descriptor is a JSON format, is a file in a JSON format for us today. And once that is done, you can go and deploy it, and that release descriptor gets promoted into the environment which you are triggering the deployment for. This is how you track a test. So once you deploy it, tests are getting run on that environment. Sentinel will track, where, which configuration the test ran against. So a QE engineer or a QA manager can go and check what is the configuration that the test ran against. And based on that, they can take care of signing off a descriptor. So this is about how you would sign off a descriptor. So basically, you would go select the release that you want to sign off. And then you go and say that, I want to sign off on a particular environment. And you go and say, select the release descriptor that you have ran tests on. So it will only show you release descriptors against which tests have run. You select the release descriptor. And here you will be able to say if you want to promote it to the next environment. So in this case, the next environment that is there is pre-prod. So you can say, yeah, I want to promote it to the next environment, and then go ahead and sign it off. So this will result in the release descriptor being carried forward to the next environment in the cycle. Right. So that's primarily on the release descriptor. This cycle continues. It goes into pre-prod. We have a similar process on pre-prod before it gets deployed into production. Yeah. So this is the last topic that I wanted to touch upon. Probably I just have another 2-3 minutes. So I'll make it quick, right? So we have vulnerability management, right? So during our initial cycles, when you are developing a feature, vulnerability management is not something that is on top of mind, right? All development is based, a lot of development is based on open source libraries. Today, our supply chain, is coming from several different sources today, right? And they are, almost all of them have vulnerabilities in some form or the other, right? So what we wanted to do was bake in the process of vulnerability management early in the cycle, right? So we wanted developers to be able to, even before they deliver something, be able to find that it is vulnerable. So we have adopted tooling that, the vulnerability management tooling sits on the IDE itself. Whenever they include a jar or a library, it will tell them, there is a vulnerability. So that is one part of it. The other part of it is, we have provided tooling from within Sentinel where a developer can go and scan their images. So your source code may not have vulnerabilities, but your OS images, your underlying images may be vulnerable, right? So that you can detect as part of DIY tooling for self-scan. Other than that, you also have scanning baked into the continuous integration. So our continuous integration cycle takes a policy file. You can define, what kind of rules you want. So you can say testing should be 80% pass rate, vulnerability, 0 critical, 0 high. Unless you meet those kind of policies, you will not be able to proceed with the next stage of your promotion of your code. We obviously have some exceptions in place. Sometimes there are genuine scenarios where vulnerabilities cannot be addressed, either because there is no fix available, or maybe there is no bandwidth, or there is a backward compatibility issue due to which in the immediate future we cannot fix it, but we'll take it up later. So in those cases we have exceptions that we can handle. This is just showing our the CI process. We do the build, the image scan, the deploy, and the test. And in this case, if you see, the image scan is red, so that means a critical or a high vulnerability was identified. And the screen below is basically how you would request an exception for a vulnerability. So one thing that we noticed was, we were doing all these proactive scans, we were creating, the CI was running, the developers were running their own scans, the 24-hour scans were running. But at the end of the day, unless you create JIRAs, it doesn't get resolved. So Sentinel, we baked into Sentinel that every night when the scans run, automatically creates vulnerability management, vulnerability JIRAs, and that there is a place for developers and program management to go and schedule these, right? So you may have a lot of processes in place, but unless you enable uh, program management to be able to schedule these tasks, it is difficult to get done. So that is something we noticed, right? Some of the immediate metrics that we got, because of the vulnerability scans that we did, MTTD, the mean time to discovery of vulnerabilities was less than 24 hours. This means that, if a new vulnerability is reported against an existing library, um, it takes us less than 24 hours to report it in our database. So we know that, okay, there is a vulnerability, and if it's critical, it gets flagged in our system immediately. Um, we have an SLA that, if there is a critical vulnerability, it will get solved in 30 days, and if it is high, it will get solved in 60 days. Since we have implemented with this within Sentinel, our conformance metrics have gone up, right? So we are almost 95% for 30-day critical vulnerabilities and 90% for high vulnerabilities, meaning that 95% of our vulnerabilities which are critical will get resolved within 30 days. And these numbers used to be less than 35 and less than 50 a few months back. That's pretty much I had. If you look at our tooling, there is a lot of functionality that is available open source. There are tools that do a lot of this functionality, for you out of the box, commercial tools. We evaluated quite a few of them. Each tool had their own strengths, and there were some things that they did not cater to. For us, specifically, vulnerability management and test tracking and release descriptor concepts were very central to what we wanted to do, and that's one of the reasons why we went to build it on our own rather than buying some of these pieces, right? And obviously, it was more fun to build, right? So we have taken that up as an exercise. It comes with its own overheads. Maintenance is a big deal when it comes to this kind of tooling. Your developer productivity, if anything is wrong in this tooling, your developers are going to be impacted, right? So there's a lot of work that goes in behind this, right? So unless there is a commitment to do that, better to go for a buy rather than a build, right? Yeah, that's all I had. Thank you. Yeah. You want to?
Yeah.
Mike?
Sorry, maybe you can come down here. Yeah. Thanks.
How do you allocate resources for resource-intensive testing, dev testing, while creating the virtual clusters?
Right. So this is one thing that we did not talk much about. But we use Kubernetes even for that. We have Argo workflow orchestrators. So we are using whenever we have a test to run, right? We bring up predefined resources within a Kubernetes cluster using the Argo workflow. It is a separate. So when we bring up this product cluster, we don't use that compute to run the test. We would bring up a separate cluster to run the test against this.
Right. And how about the external third-party dependencies for testing in these clusters? I assume the dev might be doing rigorous testing while doing integration or some their feature testing, then it might get cost effect also, right?
Correct. I mean, so whatever we can implement internally, right? I mean, a good example could be, we use a distributed data store, an HDFS implementation in MapR. That's a third-party appliance that we have, right? So wherever that kind of testing is needed, right, we have one cluster that we have installed so that we can test it against it, right? That is one case, where we could do it. But there are cases where you cannot get something in-house. It could be an Oracle server, for example, where we couldn't bring it inside. We would go in for a subscription model on a cloud. For the duration of the test, we would take that resource, run the test against it, and then relieve it. Right? That capability is not first class within Sentinel today. Those are some things that developers on QE should work to get that done as and when needed.
So right now, how many services are currently being hosted in that cluster?
So the control plane that I showed, right, there are about 54 services that are there. Those are the essential services. But apart from that, there is a lot of monitoring services that are there. About 60 to 70 services are getting hosted within that Kubernetes cluster.
And all of this we can debug using, for example, Datadog. We can get
Oh
the
yeah, yeah,
logs.
and actually, we do have agents running in each of these pods where the logs are getting sent to OpenSearch today, and we can use that to debug our services.
Okay. So it's like well maintained, everything end-to-end environment for the dev testing
It
for
is,
debugging.
yes,
Okay.
yes. We're still building quite a lot of functionality, but yeah, I mean, at this point of time, it is fairly comprehensive.
Makes sense.
Thank
Thank
you.
you.
All right, if there are no more questions, thank you for your time. Thanks.